All right, so in this video, we are just going to cover the first page of the Unit 4 Physics Study Guide. Up top, we got our vocabulary words. Relative velocity, this is going to be the velocity of a system relative to another system. So we can imagine if we had two different cars on the freeway, and one was going like 80 miles an hour and one was going 60 miles an hour. According to the blue car going 60 miles an hour, the orange car would be passing it looking like it's going 20 miles an hour faster. So that would be the relative velocity there. And then reference frame is a coordinate system where motion is viewed. So your reference frame is basically from wherever you are. So if you're in the blue car, that's your reference frame, seeing the car go 20 miles an hour faster than you. But if you're just standing over here on the sidewalk and you're seeing that orange car go by, that orange car, according to your frame of reference, would be going its full speed, 80 miles per hour. So the reference frame is, where the motion is viewed from. A projectile is just any object shot through the air, and the trajectory is the path that the projectile is going. And then we talked about uniform circular motion. In order to be uniform circular motion, the object has to be going at a constant velocity, and the circle has to have a constant radius or be the same size. And then period is going to be the time it takes to make one revolution or one full spin in a circle. One full spin around the circle. So what is the shape of a trajectory? These are going to be a parabola. They're going to they go up and over, or if they're released horizontally, they're half of a parabola, but they're going to be parabolic in shape. What is the vertical velocity of an object when it hits its highest point? So we can imagine if something's going up and then it comes back down, at that highest point, the object is not moving up or down. It's got a velocity, a vertical velocity of 0. I'm going to say Vy here equals 0 meters per second. It's transitioning from up to going down. If you launch a marble while running with the marble launcher, the marble will fly farther than if you shot the marble while holding the marble launcher or while standing. The answer would be the marble would go farther if you held it while running. If you ran, the marble would go farther. And this is because you have to add the horizontal velocity. So you would have to add the velocity of you running to the horizontal velocity of the launcher. We could just say because you add your velocities together. What are some assumptions we have to make about horizontal velocity in order to make projectile calculations using algebra? So remember, I've been writing off screen here. An assumption we have to make is that there's no drag / air resistance. Another way of saying that is your horizontal velocity stays constant. It is not slowing down as it's going through the air, which is not always accurate, but for the problems we've been doing, it's actually pretty accurate because the shapes are pretty aerodynamic and we've been going over pretty short distances, not long distances. A marble is launched with an initial velocity of 5.35 meters per second at an angle of 40 degrees. Calculate your horizontal and vertical velocity. This is a question where you have to break down your vector into components. So our velocity is 5.35 meters per second. And, we could draw some dotted lines here. We know the angle of this is 40 degrees. So if we wanted to break this down into Vx and, sorry, let me use a different color here, and Vy, then Vx would equal your velocity times the cosine of 40 degrees. And your velocity is 5.35. So Vx equals 5.35 cosine 40, or let me grab my calculator. That would be about 4.1 meters per second in the horizontal direction. For the Vy, it would equal V, which is 5.35 sine of 40. And we could plug that into our calculator. And we get about 3.4 meters per second in the y direction. Describe the direction of velocity at any given time if an object has uniform circular motion. So the velocity is going to be constant, is constant speed, and the direction is what's changing. So the direction of velocity is tangent to the circle. So if we wanted to draw a picture, if you got a circle here and it's spinning around, we'll draw some arrows. When you're right here, the velocity is going to be going in this direction. And if you're right here on your circle, the velocity is going to be going in that direction. It will always be tangent to your circle. What is the direction of centripetal acceleration? It always is toward the center of the circle. And again, we could draw a little circle here. And if your object is going around, the centripetal acceleration is always pulling inward. And again, you can imagine, if your velocity right here is going this way and you're accelerating downward, that would pull your object exactly in this circular direction. And if you are at this point right here and your velocity is going down, your acceleration would be also going inward. So that would pull your object around this way. And it continues and it makes a circle. What is the agent of centripetal force for a car driving around a sharp curve? This is going to be friction between the tires and the road. If there's not enough friction, that car is going to fly off the road because the centripetal force won't be enough to keep it in the circle on the curve. So that is the first page. I will be making a few more videos of the study guide, so you can watch as many as you want.